Hello and welcome to this IEEE Young Professionals webinar. Today we have a webinar on the introduction to robotics, coming to us from India. Actually, Gopalakrishnan is an assistant professor from Saranathan College of Engineering. But before we get into the actual webinar, I just have a couple slides to go through. I can introduce myself. My name is Matthew Carius. I'm the webinar specialist for the MGA Gold committee. I'm also the Young Professionals Committee. I'm also the vice chair for the Communications and Marketing for the IEEE Young Professional Global Committee as well. And if you don't know, we've been giving monthly webinars in 2015 on a wide range of topics: communication, leadership, and then again, like today, we have a select technical topics on robotics. So please, throughout the webinar, if you have any questions, type them into the question box below. Vote for your questions. If you don't have a specific question, you can go ahead and vote for the question that you want answered. And however, all questions will be answered at the end of the webinar. So I'm going to spend maybe a couple of minutes talking about a new initiative we're having at the global level. We're going to be promoting free meetup events at high impact global conferences for IEEE young professional members around the world. So we're actually trying to hit every single region in terms of high impact conferences, and we're actually going to have young professional events at these individual conferences. So in region 8 in Dublin, Web Summit will be there. Region 9, COP10 and Honduras will have an event there, and these are all free meetup events at these conferences. So guys, please you'll get emails about all the events, and go ahead and join these conferences if you're in the area. Connect with young professionals online. Follow us on Twitter, Facebook, LinkedIn. We have almost 100 or maybe even over 100 videos on YouTube. We also have 2 career-based services that I'm going to be talking to at the end of the seminar about: Mentor Center and Resume Lab. But today's webinar, I'm sorry for the typo up there, it's actually on the introduction to robotics. Gopalakrishnan.R is an assistant professor at Saranathan College. He's been there for quite some time now. He's very enthusiastic about robotics, and he's going to be telling us just a slight intro on robotics. So Gopalakrishnan, please go ahead with your webinar, and thank you for giving this.
Thank you, Kerry.
Yeah, perfect. Go ahead. Yeah, we can hear you.
Welcome to all. Welcome to the professional webinar session titled Introduction to Robotics. I'm Gopalakrishnan, assistant professor in the Saranathan College of Engineering, Tamilnadu, India, from the Department of Instrumentation and Control. Today we are going to look into the overview of robotics, need for robotics, classification, structures, actuators, drivers, control systems, sensors, machine and programming, and the future of robotics. Robotics is a platform which covers and comprises of different areas of engineering like mechanical, electrical, and computer science precisely, where we will be dealing with construction, design, applications oriented to robotic platform. In the origin, robotics started with the 3rd century BC, and in 1922, Sikh author named Carol Swift wrote the story called Rosem Universal Robot, where he had a play and he named the robot called Roberta, which means a worker. In 1954, George Yule developed the first programmable robot. And again in 1955, David and Handberg developed the homogeneous transformation matrix for the traverse condition and motion for robotics. In 1962, Animation Industries was formed, where a animated robot was first created and installed in the industry. And in 1973, T3 model of robot was introduced. Actually, it is a articulated type of robot, actually, which is going to imitate a human actions, and it became very popular in industries. Coming to the need for robotics, there is actually 3 kind of needs why we are going into for robotics. First need, human beings are being very dangerous to several types of actions. So we are going in for use of robotics in a place such as chemical plants, nuclear plants, military operations. In those kind of areas, we'll be going in for using a robot which precisely reduce human effort and can reduce the dangers to humans. And coming to the second use, robots can reduce the job which is going to be very stressful, boring, and labor intensive for humans. It is going to be very useful for humans in the areas where it will be very difficult for humans to continuously do jobs or 24 hours. Thirdly, in this technology and develop situation, we are going in for use of robots in several areas. Like in metros, the robots are used in cleaning of underground drainages, tunnels, etc. Where it will be very difficult for incorporating humans in those type of actions. Applications. Coming to the applications of robotics, there are several areas and there is not going to be a single area where robots cannot be used. Like in general purpose robots, we have industrial type of robots, educational robots, military robots, healthcare, research robots, and entertainment robots. In case of coming to the example of several kind of robots, industrial robots, we are using robots for welding, spraying, painting, pick and place. Coming into educational robots, we are using computers. Computer is a type of robot, and we have projectors. And these are robots which actually reduce human effort. Military robots. In military areas, we are going in for use of robots for actions which may endanger humans, like surveillance, etc. In healthcare, we are using robots for diagnosis. CCD scans we are going in for endoscopy, etc. These are robots which will actually come in handy for those type of operations. And we also do have entertainment robots. In these days, we have created a humanoid robot which actually play a song, which will be able to give us certain application, which will be able to give us a situation where we feel homely. Structures. Coming to structures of robots, there are different types of robots which have a different type of structures. Like robots can be incorporated with Cartesian coordinates, where it will be able to traverse its motion condition in x, y, and z coordinates. And we do also have cylindrical type of robots which move in cylindrical directions, and spherical robots, articulated robots, and scalar robots. Articulated, articulated type of robots, these type of robots actually imitate the action of human beings. Like there are different types of articulated type of robots like Scala and Puma. Scala is mainly limited to actions of x, y, and z coordinates, whereas Puma is restricted to the motion of cylindrical motions. Actuators and manipulators. Actuators and manipulators play a vital role in control and motion of a robot. As we say in a human arm, manipulator is a human arm. Actually, actuator imitates the actions of nerves and bones. So a manipulator is a whole arm which controls the action of any given system, whereas the actuator plays the role of incorporating the actions of manipulators. There are different types of actuator which we use in actually in these areas like pneumatic, hydraulic, mechanical, and electrical. In pneumatic type of actuators, we will be using a air control mechanism, whereas in hydraulic, we'll be using a liquid control mechanism. In a mechanical, a piston will be actually doing a role of controlling a motion of any manipulators. And in electrical, we do have several different types of motors, DC motors. Specifically, we are going in for DC motor because we'll be able to control the path with DC rather than going in for AC. In DC, we will be able to get a precise action and precise movement, whereas in AC, we won't do have any controllers. So in DC, it will be easy for us to go in for control. Drivers, as do since we do use DC motors specifically for robots. We are going in for drivers. Drivers are used generally switch over to AC to DC mechanism. There are different types of drivers we do use for these types of robots as electronic switches plays a main part in these types of drivers and electronic switches like thyristors, BJTs, MOSFET and these types of uh, switches actually do us give us a main role as in a mechanical switch will be only human being will be able to control the on and off operation. Whereas in these type of drivers will be going for automated mechanism where the electronic switches may be used for automated direction controls forward or reverse motion of control. And going in for a PWM technique will be able to control the voltage into a system by pulse width modulation and we also do have different types of bridge circuits. Bridge circuit is a particular type of configuration with these different types of switches. Every different types of configuration give us a particular type of application. Whereas we do have different types of circuits like hash bridges, reciprocal bridges, R-DEM, bipolar type, and also we do also have a resonant type of bridges. And these bridges specifically give us uh, significance of what they are going in for a particular type of applications. And coming into control systems of robotics, there are two different types of control system: non-servo system and servo system. A non-servo system is a system where when we are going to give an input to any system, output will be coming without any change of interference, where errors won't be corrected. Whereas in a servo system, we'll be actually having a feedback where the mechanism will be able to rectify the errors in the system. So from the feedback, we'll be going to give it into a input system where we will be having a controllers, different types of controller which will be able to control the errors in the system. So controller meaning will be having different types of components like integrators, differentiators. So when we are going for integrators, it will be what we call it as PI system, proportional integrators. When we are going to have differentiators, we call it as differential system, proportional differentiators. So these types of system gives us errors correction and a mechanism. Sensors plays a main role in any intelligent type of robots. There are two different types of sensors: contact sensors, non-contact sensors. A contact sensor is a sensor which actually comes in contact with any object near to the robot, whereas non-contact sensors are called non-tactile sensors, which do not come to contact with any object of interference with the robot. Actually, we choose sensors basically with the characteristics and the application of our robotic purpose, like cost, size, weight, type of output, interfacing, etc. And coming into non-tactile sensors, there are different types of sensors like proximity and range sensors, which are used for the purpose. Proximity sensors are used for low-level distance applications, whereas range sensors are used for larger distance of applications. There are different types of proximity sensors like inductive sensors, Hall effect sensors, capacitive sensors, ultrasonic sensors, optical sensors, eddy current sensors, which are used for the purpose. And in range sensors, we do have a light sensor which is based on light and ultrasonic sensor which is based on sound. In inductive type of sensors, we'll be using it only precisely for metal type of object to be understanding to a robot. And particularly coming to a proximity sensors, they are used for detecting a type of object. What is the type of object? Type of material it is used. So for detecting a type of object, we are going in for proximity sensors. Whereas range sensors, we are particularly using it for detecting a range of object with respect to the robotic mission. tactile sensors. Coming to tactile sensors are actually used for understanding purpose. Like robots will be able to understand and feel the object. So there are two types of tactile sensors like touch sensors and force sensors. We could say a touch sensor is kind of switches which will be able to observe information about a shape of object, size, type of material, etc. Plunger, LED, and light sensors are used for these type of mechanisms. Coming into machine. In the past, human eye did what no machine could do, locating and positioning work, tracking the flow of parts, and inspecting output quality and consistency. Today, the requirements of many manufacturing processes have surpassed the limit of human eyesight. Machine vision provides the manufacturing equipment with the gift of sight. Whereas when you are going in for human eye, it is limited to function of what a human being could observe. Whereas when you are going for machine vision, we'll be having an absolute tolerance of we could be able to observe and analyze the parts of any area which could be analyzed. Difference between human versus robot. Robot advantages are strength, accuracy, speed. It does not tire. It can be used for repetitive tasks, and it can also able to measure and give us the absolute measurement. Whereas human advantages are intelligence, flexibility, adaptability, skills, and will be able to learn and estimate. Coming to the robotic vision. Robotic vision may be used for process of extracting, characterizing, interpreting information from a three-dimensional world, what we call as 3D imaging. And we will be also able to analyze the image, what is the type of image, coming to any industrial oriental application. Uh, Robot in an industry will be able to acquire image from the given task and it will be able to analyze the product and also give us the est- estimate error and it will be also able to correct the error. And what are the fundamental tasks involved in robotic vision? First is a part of transformation, image transformation. What we call it as transformation of analog image to a digital field. So we also using a grayscaling in those type of image transformation. So analyzing, coming to analyzing part, robot will be able to analyze whether the image is in a proper condition or the particular object is in a proper formation. And also it also understands the uh, product which is to be analyzed. Generally, in any robotic vision, we have object verification, tracking, fast extraction of stable image features, object model acquisition, efficient indexing of a model database. These are the primary tasks which will be incorporated in any type of robot in a vision system. And we are also having a different types of vision module like which is used for acquiring images through a robotic medium like sensors, special vision sensors, fiber optic sensors, laser sensors, ultrasonic transducer sensors, passive infrared sensors, and also generally in older stage we were using a radar system. Generally, in recent trend we are not going for radar system and a vision dimension. So actually, vision from a robotic model can be taken in two type of medium, like stereo vision and active dynamic stereo vision. A stereo vision is a medium where the robot will be able to acquire 3D image from two different standstill image. Whereas in a dynamic stereo vision, a robot medium will be able to acquire vision through a running image. Whereas what we call it as active or dynamic imaging. The robot will be able to acquire a running or a processing image. And actually, this is the working model of a machine vision system. Here we are having a sensor head which will be incorporated with a light system and a vision system. Light system is used for acquiring image with a clear understanding, and the sensor will observe the image and it will be taken to the processing unit, where a processing unit will be able to understand and analyze the image which is being acquired through a sensor. A sensor senses the actual imaging from any processing unit. This is an actual example of any industrial oriented process. And from the process, we are taking the signal to a robotic medium, and what we call it as a robotic arm. It is a articulated type of robot, mainly which is used in a industrial purpose. So, end effector plays a vital role in any operation. End effector, we do have different types of end effector like grippers, holders, sprayers, cutters, welders. So, actually, end effector is a part which makes the whole system run. So, end effector does the process of ejecting or continuing process. Here, object is taken into the medium, and effector picks or rejects the actual part of the system. These are the components which are used in machine. Lighting, camera, part sensors, imaging, processing, inspection software, communication, and networks. So lighting, as I told, it is used for a clear understanding of object in a processing unit. A camera is used to observe the analog signal, and a part sensor also used for observe the object. Imaging. Imaging is used to convert the analog signal which is being acquired by a camera and sensor into a digital imaging. A processing unit makes the analyzing and the processing part, and the inspection software inspect the object from the processing station and rejects or allow the process to be done. A communication network holds the communication between all the system in a processing station. Programming. So programming plays a vital role in any robotic medium. The programming is actually a task which is being created inside any robot. So there are two types of programming: online programming, offline programming. So in these days we are using only offline programming, whereas online programming there are two different types: teach pendant method and lay through programming. Teach pendant method is a method where we will be recording accurate traverse condition of robot motion into any handheld device. So a user will be able to traverse the robot in particular type of motion. So it will be restricted to any single kind of action only. Whereas in lead through programming, we'll be using a continuous motion of the same part which we'll do in teach pendant method. In our lead through programming, we are going to create any recording sequence of any robotics function. So when the recording sequence is being created, robot will be able to lead through the recording programming which is being sequenced. So coming into offline programming, there are different types of offline programming which can be incorporated into a microcontroller of a robot. So microcontroller is a main part of a robot which can be able to make whole system work. So these microcontrollers have to be specialized with any type of languages which is understandable to the microcontroller. There are different types of languages like AML, BAL, AL, RAIL, Robotics Studio, Code Composer, Kyle, etc. Motion control. So motion control is an actual platform which used to control the motors of a robotic medium. So point to point control, continuous path control, control continuous path control are three different types of motion control which is being used in any robotic medium. So point to point control, as I told earlier, in a teach pendant method, a recording mechanism. You have single point to another point. So a recording sequence for actually a part of robot will be created. So the point at which exactly a robot should start and it should end will be recorded. So robot will be able to traverse its motion according to the point which is being recorded. In a continuous path control, a several different recording sequence will be created and a robot will be able to continue its path through the whole recording sequence and it will be in a continuous motion. So without any user interference. In a continuous path control, there will be any controlling mechanism which will be used in these type of robot where a robot will be able to overcome errors inside any control system. So laws of robotic and intelligent systems. In higher types of intelligent system, there are three different laws which is being used. These laws has been invented by Asimov, the author and creator. So, law one: a robot may not injure a human being or through inaction allow a human being come to harm. Second law: a robot must obey order given to it by a human being, except where such orders would conflict with higher order law. That is the first law. So a robot must obey the order given by human being, and also it should not conflict the action with the first law. That it should not harm the human being. And third law: a robot must protect its own existence as long as its production does not conflict with first and second law. As it says that a robot must protect its own existence as well as it should not injure a human being or it should also obey a human order. And these laws has been incorporated in a humanoid robot and robots which are used in industries. So as it doesn't comes in conflict with human actions. Building a robot. So what are the necessary conditions to be taken while considering building a robot? We are going in for three different primary tasks. Like what are the primary things to be considered? While going in for creating a robot, we are going in for considering exactly what is our application. So we have to consider a robot according to its own application. There are different types of application as I said. So application may be a pick and place condition or welded condition. A robot we can be using it for loading, unloading purpose. There can be a indefinite type of application. For this type of application, we are going in for considering a primary task. So after considering the primary task, what is the type of structure we are going in for? So structure like as I said, Cartesian coordinates, cylindrical coordinates, or as we have to go in for spherical coordinates or articulated type of robots. And once we have considered the primary task, we have to go in for considering the components. So we have to go in for components like sensors, motors, platforms, what is the type of programming we are going to use, whether we are going to use for offline programming, online programming, etc. As we consider the component we have to go in for, the component should be chosen according to the primary task which is being considered, like application. We need not go in for larger range of components for a smaller purpose. So, and also we should not go in vice versa as a smaller range of components for a larger purpose. And we have to create a platform according to the structure it is going to be created. So the structure is like a platform as it is going to be in a mobile platform or it is going to be in a mobile platform, etc. So once we consider these tasks, we are going to of robot we prefer. I believe that's the end of the session with the future of robotics. The future of robotics comes with large of application like artificial intelligence, autonomy, humanoid robots. We have different types of humanoid robots in these days. where we will be able to get applications like robot may be used for getting us a new song according to our mood. Robot will be able to cook for us. Robot will be able to design structures, cut well according to nature of what a human being prefers. A robot may be a assistant of human in the future. Comments and feedbacks.
Thank you very much for a very informative webinar. You've just given us a very big overview right now. So yeah, I'm going to invite all of our viewers to actually type in your questions below, right in our IEEE TV YouTube-based forum. I'm just gonna start off the questions, I guess, with where do you see the future of robotics going? Maybe in the next five to 10 years, where do you see the future of robotics going?
Yes, in the future of robotics will be humanoid form, where human being will be able to actually acquire basic tasks and needs to be fulfilled by a robot itself. And it is not necessary that human has to go in outside to get the objective done. I believe in 2030 or 40, robots will be main help for a human being.
So you think that the price point for robots are going to be able to be introduced to the home more readily in the next 10 to 20 years?
Yeah, absolutely.
Okay. We have another question coming in here. What is your most favorite thing about robots? You obviously have all this experience with robots. I'm assuming you've built a couple of robots yourself. What's your favorite part of maybe building a robot?
My favorite part is introducing a robot into a underwater system. I love to make a robot which actually analyze underwater technology. Actually, it is very difficult going for underwater system with a robotic machine, since it deals with many difficulties as we have to protect our robot from getting influenced with the water. So, and also there are many applications which comes under underwater technology, like identifying things which is going under water. So we are also using different types of robotic and naval applications where robots are created to analyze and read the situation underwater.
Okay, that's very interesting. Have you ever built a robot yourself? I'm assuming you have, right?
Yeah, actually,
Yeah.
We have a situation here in Saranathan College of Engineering in our college. We are having a robotic club, and we do have a student who regularly comes and build different types of robots. Like recently, we have created pick and place robots, and in last semester, people were doing robotic missions for a vision system with a finger edge technology, etc.
Yeah, that's really cool. That's really cool. I don't think we have any other more questions coming in, so I'm gonna actually thank you for an excellent webinar and a very good overview on actual robots. I'm actually going to talk a little bit about to our audiences now. Thank you all for participating. Please complete the feedback survey I'm going to be sending out right after this webinar. Just a heads up, our next Young Professionals webinar is on August 24th, 2015 at 11 a.m. Where Armando Biondi will be talking about ideation and validation for entrepreneurial success. He's actually an angel investor. He's invested in many different companies, and he's going to be talking to us about what actually is the recipe for entrepreneurial success. Please check out these two career-based services for young professionals. The first being a mentor center, which it's kind of like a dating site for for your job, in which we try to link you up with people in your field from all around the world who have experience, who's been in your shoes, you know, a fresh grad or a young professional who's in your field, who can potentially help you guide yourself throughout your early career. We also have a resume lab, which there's lots of tips and tricks for how to build the perfect resume, and of course interview tips. If you're interested in presenting a webinar, or just want to give or just want to hear some more topics, please shoot us an email shown there, and of course all the information is available online. And with that, I'd like to end this this webinar, and thank you again for everyone participating. Thank you, and thank you again to our speaker. Thank you.
Thank you.